Good morning and good afternoon, everyone. Welcome to a new session of our Azure DataFest. As you know, the Azure DataFest consists of a number of sessions designed to give you a good overview and introduction over the data analytics and machine learning services that are available on Azure. And this is our fourth session that we have conducted. And if you remember, in the first few, for those of you at least that have attended all of the sessions, we have touched upon a number of topics which are also available online if you want to review them. But basically, we have given an overall architectural overview and introduction to the tools and services available to ingest big data, whether in a batch-based fashion or in real time, into Azure. And we have already explored a few services that then are available to process the data, depending in different ways and depending on what your use cases are. So we have touched a little bit upon data lakes and Synapse Analytics in the first session. And then we have gone through a couple of sessions related to Azure Data Explorer. And today we are here to discuss how we can plug in machine learning to derive insights and make predictions based on the data that you have ingested into the platform. And especially, we want to explore and provide you with an overview of what are the tools and services that Azure provides to train machine learning models with no code or low code, so that data scientists can be immediately productive exploring and consuming the data. Just before we start, a few notes and rule of the house. So one thing first, at Microsoft we see sustainability and humanity's response to climate change as one of the greatest challenges of our lifetime. But we believe that it's not too late to plan for a cleaner and greener future. So as part of our commitment to sustainability, Microsoft Singapore will be planting a tree for every person attending this event. Next, moving forward. I would like to discuss with you, thank you, a few housekeeping rules. So the session is being recorded and will be available on demand afterwards. And everybody is muted. However, you should be able to locate a live event Q&A panel in which you can ask questions throughout the session. And then we will be answering them on chat. However, for questions that may require a longer elaboration or some of the key questions, we will also have about 10 minutes of Q&A at the end, right? So I will be your moderator and bring your questions in the Q&A as well at the end of the session. All right, so I said this. We go to the next slide. I would like to introduce you to New Ching. New Ching is a senior cloud solution architect in the customer success unit team at Microsoft Singapore. And thank you, New Ching, for being here with us today and for taking us through on how being productive on ML and how to train no-code machine learning models on Azure. Thank you.
Hi, thank you, Andrea. Hi, everybody. I'm Nyok Ching here. Well, today I'll be going through how one can do machine learning using one of our features that we have on the Azure Machine Learning service, known as a designer. And I hope I will let you know how easy it is to train a machine learning model, even if you don't have any data science background, or if you don't even feel like doing any coding. Okay, let me introduce a product that we have in Azure. It's called Azure Machine Learning. Well, Azure Machine Learning, we designed this in mind about getting a platform, Azure Machine Learning platform that is usable to all people who are interested into doing machine learning at all skill level. You do not need to be a very fantastic data scientist, but you can be just a novice data scientist or somebody who has just started doing data science and who wants to start learning about machine learning, creating machine learning model. So the Azure Machine Learning is something that we have created for this group as well. So we do have user interface and features that will help people who have no knowledge on data science to start doing machine learning model training. In this platform, we also have full lifecycle management with something called the machine learning operations, which is called MLOps. It integrates with our Azure DevOps and also GitHub. It allows you to do deployment of your machine learning model, monitoring data drift, which is if you have noticed that the machine learning model, deployed machine learning model, is not doing as great a prediction as what you have trained after being deployed into production. You can also do retraining with this MLOps, and then after retraining and deploying into production again. And well, Microsoft has been in the AI community for very long, ever since Bill Gates started Microsoft research about 20 years ago. So we definitely incorporate a lot of state-of-the-art machine learning into this particular platform, including things like responsible machine learning. Here we have incorporated many of features that will help you to develop responsible machine learning by including tabs to tell you whether your data is being fair, how your machine learning model is being trained, whether it contains any bias in your data, whether it's being transparent, and whether it's interoperable across all the different data sets. So we have we incorporated this in the platform as well, so that it makes it easier for you to create a machine learning model that is more responsible. Well, definitely, lastly, we are really open and interoperable across all the deep learning framework or the machine learning framework that we have in the AI community. In fact, Microsoft is one of the active member of the AI community, and we contributed a lot to the AI community as well, which is why this platform is actually very open. You can run all your PyTorch, your TensorFlow models here, train and run it here. And we keep in touch with the latest and greatest technologies that's advancing in the AI community. So you can actually just clone any of the GitHub repository you can find in the open space, and then start training and learning within this platform. Okay, so I'll give you a very high level view of what Azure Machine Learning services. But obviously, when you do machine learning, you not only do structured data from your databases, but also that you can do unstructured data, especially when you're dealing with vision, custom vision, for image recognition, and also about speech. So we are able to make use of both structured data and unstructured data, and then you can use those data and to create any machine learning models that you'd like to meet your business objective. And on the top here, we have a suite of user interface, studio experience for the different skill level that we mentioned about just now. We do have the notebooks, which if you are a data scientist or you are very code savvy, you can definitely use these notebooks for your training of machine learning model. And we do have something called AutoML. It's actually an augmented version of AutoML that you normally see. We use scikit-learn and all the open source packages. I will show it to you later, run through on what this AutoML is. And lastly, we have the designer, which is drag and drop feature that we have here, and this is our focus of the presentation today. And of course, if you like to use visual code or some command line, you can definitely use that. So BD for that, obviously we have the comprehensive ML ops capability. We can reproduce, we can automate and deploy things like that. Like I say, we can retrain when you notice that the data drift. And of course, they are all supported by the powerful compute that you need to train and run those models. So, well, our candidates, our GPU is definitely supported in a machine learning model here. Okay, next. So I'm going to zoom into the tree interface that will allow all skills get to start creating machine learning model. So the first one I'll go through will be the notebooks. Well, if you're familiar with Python notebook, this is exactly the same as the Python notebook. And we do something more than the normal Jupyter notebook that you're familiar with. We can actually do collaborative coding. If you can see on the screen here, it's almost like Word document. You can have two people editing on a cell together. So it's something like if you feel like having a collaborative development on the platform, it's definitely doable. So you can put comments as well, like what you do for a Word document. You can also comment on other people's codes as well. And of course, we will have IntelliJ, so to help you quickly search for the functions that you want to use and also the parameters that's being used by those functions. So this is the, I would say, a really augmented Jupyter notebook that you are familiar with if you're one that's doing coding for machine learning model. So the second portion I'm going to talk about will be something called AutoML. So for people who are doing machine learning model, the traditional machine learning model, or even the deep learning ones, you realize that it's difficult for you to do hyperparameter tuning. It's actually a chore because you have so many parameters to choose from, and you have a range of values that you can choose for those parameters value. It's actually very tough to keep track. In fact, last time I used to use Excel spreadsheet to keep track of what parameters I've used and what values I have. Or even if you use grid search CV inside scikit-learn, I will still maintain a list to know what I've actually used, so that to mentally know and record what are the things that use and what are the results of the parameters that I've used. So having that in mind, Azure Machine Learning has this feature called automated machine learning. It's available in two flavors. If you are not somebody who's comfortable to do coding, you can actually use the UX, which is what you're seeing here. So you can just select the dataset, configure run, and then you can just let the Azure Machine Learning platform to do all the parameter search for you. However, if you are doing coding, you prefer to do it via coding, we do have the full suite of SDK for automated machine learning. You can use the SDK as part of your Python notebook and Jupyter notebook, and then you can still run the same thing without using the user interface. So in case you're not aware of what is what am I referring to when I say parameter tuning is time consuming, just imagine the cycle about model creation. So when you want to start creating a machine learning model, you have to decide which are the features that you want to use for your machine learning model. So let's say you have a list of 100 features. Which are the features that's most suitable for the machine learning model? You have to figure out. You have to spend time looking at the data, doing some calculation, and even just testing against the machine learning model to see whether the features are required. The second step you need to do is to think of which algorithm to use. There are so many algorithms you have in out of the market, like gradient boost, nearest neighbor. So the list of the algorithm goes on and on. You also need to choose which algorithm is the best for your business objective. And each of these algorithms has tons of parameters for you to try out. And each parameters can accept a range of parameters value. So if you can understand the cycle of doing machine learning creation, you will realize that there are a lot of combinations that you can do of just these three columns of things that you need to choose. So let's say I've used Excel spreadsheet to sometimes keep track. Like I say, I select these 3 features and I choose gradient boosted, and these are the parameters that I use, and these are the variables I have chosen, and it gives me a 30% accuracy on the model. So imagine the number of permutation I have to go through for this entire thing just to make sure I create a machine learning model that's suitable and have high accuracy based on my business needs. So okay, so for machine learning, for automated machine learning, we actually automated the 3 parts, the 3 pillars that you see just now. So it's not only about hyperparameters value selection, but it's also about hyperparameter selection itself, feature engineering, and what algorithm to choose. What you need to do is to provide a data set, do a little bit of configurations, like telling them I'm going to do a classification, I'm going to do a regression, or I'm going to do a forecast. And I do put in some constraint. For example, what is the accuracy metrics that I want to use, whether it's area under curve or is it F1 score. You can specify, and also the values that you expect the models to attain. And these are the configuration that you can put into auto machine learning. And once you get this started, the auto machine learning will actually do feature engineering for you. And you also do algorithm selection for you and do hyperparameter tuning for you. So the 3 things that we had to do manually previously is all done within automated machine learning. So it becomes very easy for anybody to start coding and also to take and increase their productivity if you leverage on this feature called automated machine learning. So I personally thought that this is a good feature for Crow because I have a hard time trying to do algorithm selections and parameter tuning. I'd like to know feature anywhere I have thousands of features to look for when I have to do a machine learning model. Okay, so those 2. Okay, let's go to the next one called the designer, which is the focus of our talk today. So a designer is actually we designed this feature and putting inside Azure Machine Learning is because we realized that a lot of people now, given that doing machine learning seems to be very cool, very sexy, and there are a lot of people who wants to do it, but they are scared of doing it because they thought they don't have a foundation of coding. They don't know what data science is. So this is actually designed for people who are new to machine learning. They want to learn machine learning, and there are people who are just starting out, have some background, but it's still pretty new. They just want to get their hands dirty and try it out themselves. And also for machine learning experts who just want to do quick prototyping. So this is actually a drag and drop design. Later, I will give you a demo. Basically, you drag and drop things that you want and then put it on the canvas and you connect them out with arrows. And this then will be going under machine learning training. And then you can actually visualize whatever data you have within this drag and drop panel designer as well. And then you can, after training and you felt that the model is good, you can actually just do a one-click deployment. And if you don't do any custom code, well, you still can do that by writing some Python or but if you don't do it, then it's an entirely no-code process. You can drag and drop, create, transform the data, select the algorithm, and you can train it and then deploy it directly and without having a single code to be written. Okay, I guess it's good to have a demo of what is going on. So today, what I'm trying to show you will be a no-code restaurant recommender. So this is the final product that we are going to have. And maybe I will touch on what is recommender. Recommender is generally what we call a recommendation engine. So generally, there are 2 kinds of recommendation engine. One would be collaborative filtering, which means we see the interactions between the users and the items, and we will try to identify people who have the same characteristic and what are the things that they like, and then we will try to recommend it to people in the same clique. For example, my friend and I, we are good friends, we have the same taste. So what the algorithm will do is if my friend purchased something from the shop, like a purse, which is purple in color, they're generating that we, my friend and Yao Chen will like this as well because we have similar tastes. So that's why we call it collaborative filtering. So people who have liked any items that they know will generally like things again in the future. The second part we are doing will be content-based filtering. This is basically filtering based on user profile or the item description. For example, like for movies, if we will categorize it based on genre, and if we have to pick certain kind of movies, for example, like horror movies, if there is a new horror movie coming out, they will try to recommend that to me. So this is called content-based filtering. Basically, is recommending items for the same category. So, okay, this is a deep dive of the training algorithms that we have, the training flow. On the top part, you will see 3 data sets that we have. So the first data set we have will be contains the restaurant rating by the users. The second one will be the restaurant customers data, and the third one will be the features of the restaurant. What we'll do is we will split the restaurant rating into 2 parts, because usually in machine learning models, when you train the machine learning models, you will need to split the data into 2. One will be for training and one will be for testing. So we will keep part of the data to do training and part of the data to do testing. And we will use this data, the training part here, and feed it into an algorithm called white and deep recommender. Yeah, this is one of the recommender that we have out of the box. So later you can just drag and drop and put that in. So the first parameter that you put that in will be to train the data, which is the user item ratings. And then the other 2 contains customer data and restaurant data. So what we can do is we can just, these are features that is included in the machine learning model, just to let the machine model know what characteristic you have for the customers and the restaurant. Remember something about collaborative filtering, you need to find out who are the people that are similar taste and what are the restaurants that they are pretty similar. So if I give you, my friend and I like to eat pizza. So if there's a new pizza restaurant coming along, it will be recommended to both of us because we both like to eat pizza based on our customer data and customer restaurant data. And once you're done, you will have to go to a module called scoring. Scoring actually uses the testing data. And what we're going to do is want to see how good our machine learning model is. Okay, the reason why we are doing this is because, like I said, we have a lot of parameters to tune. So this is one of the ways that we can see if there's some parameters that we can tune so that we can increase the accuracy, or should we have more features coming in for the 3 data sets that we have. So by using the scoring method, we will be able to get the accuracy of this model, and then we can evaluate and see how good the thing is. This is the training portion. The next slide will be the inferencing part. So once we have get out our training model that you see on the left here, we will create a web service. And you can see a web service input here that you allow the customers to input the values that you require to score the, to use the machine learning model that we have trained, and then come up with the output. So basically what we are going to input here will be one of the users that we know, and then we will score it against the machine model that we have created, and to see what other recommendation is coming out from this machine learning model. Okay, so let's go to the demo now. Let me just go to the demo. Okay, so this is actually the Azure Machine Learning Studio. Yeah, so this is the landing page that you will see, and these are the 3 things that we have gone through in this session. Number 1 will be the notebooks, which is the Python style stuff that Python Jupyter notebooks are light stuff. Then the AutoML, and then the designer. Today we are going to talk about the designer. So this is the designer that you will see when you click on the designer button, and we can start building our pipeline here. Okay, so this is the drag and drop interface that you see when you want to create a pipeline. So on the left, you can see there are a lot of things for you to drag and drop. Well, the first data sets will be things that data that you have, your data that you created yourself. That means you can import your CSV files, your images into here, and then this will become draggable for you for your pipeline. So you have to create this beforehand. For example, you have some CSV file, you can create a data set, and then you will show on here for you to drag. So today we are going to use some of the sample data sets that I've showed just now. So you get the sample data sets are here. Restaurant features, restaurant ratings, and customers data. So see, I'm dragging quick drag and drop onto the canvas. So generally, most of the time, we will try to preview the data to do some sieving through the data. You can see we can actually visualize the data. It's actually showing me a histogram. Let me just click and see what are the distribution of the user ID that we have. Or this place ID is actually the restaurant ID, and we also can see the we only have 3. It's quite, yeah. So we have a few sets of place ID, and we have almost on this 135854 place ID, and these are the ratings that we have here. Okay, this is how you visualize the data. You can do the same for the customer data. What do we have for the customer data? Here, we have a lot. We have a user ID, we have a latitude or longitude. We want to know where the person is so that when they are near the particular restaurant, we can also give the recommendation. And these are characteristics of the users. So it makes it easier for us to recommend the same restaurant if 2 people have similar characteristics. Okay. And the last one will be the features of the restaurants. Here we have the place ID, which is the restaurant ID, where it belongs, where it's located, and also the name, the address, what is it selling, what the price, right? So these are the characteristics of the restaurant. Okay, so once we have the data in, we need to do some transformation. We need to select the data that we want to use. So let me drag and drop. Let me drag and drop the data. Let me split the data. Remember, we are supposed to split the data into like 50. Can actually search by it. So we can split the data here. So we can split the data into a training set and test set. And we can, well, we do have a lot of data inside the data set. Maybe we only need a few, so we can actually just select the columns in the data set, just select things that we need. We don't need all. And what do we need for the data set? We will need user ID. You see, we can actually just, there's no coding. I just select whatever they know that the data set has all this attribute. I'll just do that. So I want to know whether the person is a smoker and characteristics. Okay, we can select, and then we can select columns in the restaurant as well. Here. And we can do the same. Now we select place ID, longitude and latitude. And maybe I want to know how costly this, we want to read against the price. We're done. And once we are done with the data, we can select the algorithm to use. We have a lot of algorithm here. We have some statistical function when you can visualize the data. And you can, yeah, there you go. You have all the machine learning algorithm, then you have this other forest, linear regression, neural network, some small layer. We have clusterings as well and classification here. But since we are doing recommended today, we'll go to the category called recommendation. And you can actually see that we have 2 kinds of recommendation engine. One is the SVD and one is the train YND recommender. So we'll be using the YMD recommender today. And I'll drag and do the training here. Then I'll drag. That is it. And once we do training, we need to score, check whether our values are correct. So we do the training set here. And we need to train the model. So we have the train model here. Oops. Oops. Train model here. Then we will evaluate the model. Okay. I think we are done with it. So it's very easy. Select your data set, select the data that you want to train, get the machine learning model that you want, do train the machine learning model, and then try to score it against the testing data sets and evaluate to see whatever you have predicted is pretty similar to the data that you have. So I'm not going to run this because it takes a little bit of time. So I've actually done it already. So once you are okay and trained with the data here, you can actually see the evaluations of, well, evaluation means we want to score against our trained data set, whatever we have predicted using the machine learning model and what we have labeled to see whether our algorithms work correctly. These are some of the metrics that is available for YMD. So you can use mean square error. You can use the R square metrics to see whether you are satisfied with the output of the machine learning model. If not, you can modify the parameters that you have here. Well, there are so many right here. You can modify the parameters, or you can actually just see whether you want to tweak the features, add in more features, and then you can train the model again. So assuming that we are okay with this machine learning model that we have trained, we are satisfied with it, and then we want to deploy into production. We can actually do a one-click deployment, and you can just select something called the real-time inferencing pipe. And once you click this, you can see that the interface changed. We have changed from the training pipeline to the real-time interface pipeline, and you can see that there are new modules that's being added. Notably, is all the web service inputs. We do web service input that we have for the data sets. For each of the data set, we have web service input, and we will have a web service output from the machine learning model after scoring it. Well, the reason being is that all these web service inputs will be things that you can actually input based on the criteria, because you need to provide the machine learning model with some parameters and to let that return you a prediction. So that's why it automatically creates the web service input for you. It has the same number of parameters that you have for the data sets. So, and then for the output as well. So the web service will also have an output, and it is actually represented by the web service output. For this scenario, we would like to recommend users recommend restaurants to the users. So in that case, we will not need restaurant features. So I'm going to delete away because we don't need this to be included. So let me delete it away. because we only want input for the users. Let me just delete this away. And in order to do scoring, we only need user ID. So we don't need to select the rest. And we do not need restaurant ratings because we want to recommend restaurant to the users. And this is actually our trained machine learning model. And I can move this to and I can use this as an input. And I need to change this. So now we are not going to train the machine learning model. What we need to do is to do item recommendation, and we can actually recommend the item. Let's say I want to recommend users with whichever restaurants that is that our machine learning model will recommend to it. So we have to change this to become item recommending based on users and from all the items that we already know that exist. And we can remove evaluate because we are not evaluating this. And that's all. This is what we have for your inferencing pipeline. We will have a web service input where you input the user's ID, and then we'll connect it to the trained machine learning model, and we'll output the restaurants that's required that will be recommended to this particular user. Again, this is going to take some time. So actually, I have already done a similar one. And let's go and see how we can score it. So this is what you will see if you try to, when you have trained and deploy this. And you can see the green bar means it's completed. And then let's try and see, once you deploy it, you can actually see it as something called the endpoint. And here you can see the web service output. So this is the REST endpoint that I have. And this is the Swagger AI that you would see. And of course, let me have a compute startup for you. And we can actually test this test this machine learning model. Let's say I want to test a machine learning model against using the user ID U1001 and want to see what's the recommendation that's coming back. You can actually just use this interface to do a test. Or you can actually just use the JSON if you like. You can use the Swagger and then you can use the JSON and fill in the JSON values, and you will see the values. You can also do it via JSON code. So, well, I actually toggle between the two. The results of the recommendation comes out from recommended for user 1001 based on our recommendation engine. So yeah, so this is like a really no code kind of scenario for you to train a recommender. I hope this will tell you that it is not that difficult to start doing a machine learning model, and you can actually try out yourself by just doing some simple drag and drop here. And you see that I have not written a single code, but I'm able to train the model and actually create an endpoint, which is a web service endpoint here, and allow people to consume it. Yeah, that will be pretty much we have here today. Do you have any questions?
Thanks a lot, Niu-Ching. A very clear demo, and yes, there are a couple of questions in the chat. One of which I was just about to reply, and basically, once the model is deployed, what are the ways to monitor maybe the performance of the model or feedback the results on live data to then retrain the model to improve it over time? What are some of the mechanics that maybe Azure ML or MLOps provide in this space?
Yeah, so we were talking about data drift just now. So what we can do is we can actually have the scoring results into a data set, and then we can compare the drift between the trained data and the scored data. And then with that data drift that is being indicated that maybe our machine learning model will need a retraining, and you will actually just trigger ML ops to do a retraining. So we can actually just monitor the scoring data and then throw an indication that there's a drift that we have found it unbearable, and then we can just restart. Or we can send an alert. We don't need to restart a training retraining of the algorithm. Then we can definitely retrain once we have that indication that there's data drift in the machine learning model. Anything else?
Thank you, Nick-Ching. Yes, there's one question which is also quite interesting, and we provided an answer, but maybe I'll surface it so that the audience can understand it. But basically, while you were showing how to basically build the model onto the canvas, picking your modules and build the model. What about the interpretability of the model itself, right? So the example was, for example, will there be some correlation of features being used so that, to better understand what what led to a particular model. So we have answered on the chat already that in the yes, in this canvas ML Studio, you can use permutation feature importance so that you can understand what's the importance of each feature, as well as outside of ML Studio. There is a whole set of functions in the SDK that also are related to the interpretability of the model. And but Nick-Ching, would you like to add some more inputs to our answers?
Yeah, so I've just demonstrated that there's this permutation feature importance, and you can actually use this and drag and drop and then see what the features that's important to you, and then visualize it without writing any code. And as for permutation, as for responsible AI, actually is available here under the run detail. So we do have fairness explainability here, which is actually a preview feature, but unfortunately for this, this is coming up. This is actually a preview feature, but we will intend to put all this like fairness train the interpretability explainability here. So next time, if you train any machine learning model, all this will be available for you. So you do not need to do additional things to make sure that your machine learning model is you're being responsible for your machine learning model. So yeah, this is something in the pipeline. You can see here that we do we intend to incorporate it in the future. But of course, you can actually do that using the SDK as well. Or it's actually available for you.
Thanks. We have received also a couple of new questions meanwhile. One is whether the models can be trained automatically based on events or a schedule. And I think the second question is partly related to the answer to this first question. What is the difference? Basically, what is MLOps, and is automated ML part of MLOps, right? So MLOps plays, of course, a role in triggering the retraining of the models. So two questions basically: whether the models can be retrained automatically, and is automated ML part of MLOps?
Yeah, so the models can be retrained automatically. Like what we wanted to do, we can actually indicate whether they are the data drift or could be an event that you are monitoring the data sets on. And second, definitely a schedule. You can do it via ADF or whichever. You can do a regular change or regular retraining, or even use the DevOps to do a regular retraining. So this can be done by rescheduling. And your second question about AutoML, whether it's part of MLOps.
I guess clarify maybe the concept of MLOps, right? Before maybe answering.
Oh, okay. So
yeah.
MLOps is actually about well, training, testing, and deployment, and then retraining. Whether or not AutoML would be part of MLOps, maybe and maybe not, depending on the reason why you want to do a retraining on the machine learning model. Let's say if the data drift is too much, you probably want to relook at, is there a new feature that you need to do it? That's why you need to rigorously go back and look at your features engineering process. That's why you want to go back to do ML. You want to make use of AutoML. Yeah, so it depends on the situation, I would say. Yeah, so but definitely, if you feel like you want to do AutoML within the ML, it's definitely doable because it's just an API call. It can be evoked via SDK. So definitely is, but generally I will not put that inside until I really see a big change in my data and my machine learning model really deteriorate, accuracy really change a lot. And then I'll really relook at the algorithms and the features that I use. So generally, not really, but good to have if you decided that the drift is too much. Yeah.
Thanks, Niu-Ching. And okay, there's a question on ML specifically, whether data drift, when we refer to data drift, is it the same as precision loss of a model?
Yeah, it can be one of the reasons of called data drift. Yeah, it could be, it's called model drift in other communities. So it's as long as you feel that the model is not performing to what you're expecting it to be, then it's considered drift. So it could be precision, it could be due to the scoring data, it could be anything. Yeah, so as long as there's a difference between what you expect and what is actually in production is called drift. So anything that you feel that should be on, you should pay attention to what are the metrics that you want to pay attention to is considered drift, and then you can kick off and relook at MLOps, kick off MLOps and look at what we have been training on the machine learning model. Yeah. Anything else?
Yes, the session is very interesting because questions keep coming.
Yeah, there are more questions. Let me check. Yeah.
Yes, actually, let me publish this. It's not a question, but a feedback that the session has been wonderful, and yeah, and maybe some feedback for us for some of the next sessions is to elaborate further on how data scientists and domain experts and data engineers can interact using this platform. So yeah.
That would be a good one. We can show how we can collaborate using our notebooks where Andrea, you can type and I can type, and we can start coding at the same time. Real-time coding.
Yes, seriously, we treasure this feedback because we want to shape these sessions in due time to make them more and more relevant to all of you. So thanks a lot for sharing this. And another question. Are the models generating using the suite of tools compatible with other tools such as SAS and others? And,
okay, so we use open frameworks to write this. So behind the scene, it will be scikit-learn. So not necessarily compatible to SAS, but all this are runnable against and being used. We actually generate pickle file at the back. So this is generally runnable at for other open machine learning platform. Yeah.
All right. At the moment, no more questions, but maybe what we can do is if we switch back to the deck, and if I can get.
Oh yeah, sure. Yeah, forgot.
I'll elaborate on a few closing notes, and meanwhile we can see whether we receive more questions. In fact,
yep.
There's a question just now. Can you share some sample data that we can try ourselves?
So the sample data are already available on the designer. The data that I used just now is actually sampled from, it's out of the box off from Azure Machine Learning workspace. So you can just leverage on it. And you can actually just download any of the open source data that you have and just create a data set and you can start using it. So you can use also data that you can find on the web. That's plenty to play around with. It's a open platform, so definitely can use data that you find at other places and start using it on Azure Machine Learning.
One more. Will models generated using one version of Automl be compatible with future versions?
I don't think there's a version consideration here. Basically, AutoML is a set of intelligence that we have to help you choose, to quickly choose feature engineering. And the algorithms that we use are open source algorithms like scikit-learn, or we have ensembles as well. So all those algorithms are not proprietary to Microsoft. So what we do is actually just increase the productivity. So you can see gradient bows or whatever scikit-learn packages that you see. We actually have a list of algorithms that we use for AutoML, and those lists are openly available. So it's not about whether it's future-proof. You definitely can run it on. You should be able to run it on future versions of Python or future version of whatever set that you have. But obviously, like other scikit-learn packages that have been upgraded, you must have all the necessary dependency to make it run. So yeah, so the algorithm that we use in AutoML, they are not proprietary to Microsoft.
Thanks, Niu-Ching, and yeah, please, we are happy to respond to more questions. And in the meanwhile, yeah, as you have seen, this is the calendar of the sessions, some that we have run until today, and what we have for future. But before I elaborate on that, there's you may have seen noticed that there's a little bit of a mismatch here on the dates. So we are talking today about a train and no-code machine learning model dated 11 of November. This is actually it's the 28th of October, of course. What we will do on 11 of November will be to elaborate a little bit more on data governance, because we have seen how to put together a data estate, data lakes, deploy big data tools for analytics, deploy machine learning capabilities. So we end up with a lot of data sets, from raw to aggregated data set to curated data set, insights, and how to ensure that the processes that generate data and the people that have access with different levels of rows access all these data sets is very important. Data governance is key. So we will have a session on 11 of November on that. It is this getting the most out of your data with Microsoft Purview, where Purview is the Azure services that can help give an implementation to data governance. And then we will continue on for the rest of the sessions in November and then December, also talking about the infrastructural topics that are important when you want to deploy these solutions that manage and process your data into production. And so that poses, especially when we talk about large data set, that poses significant challenges when it comes to topics like networking, security, how you audit and visualize threats that may be happening to your data. And so actually our Azure DataFest that was initially conceived only for the month of October has been extended with all these set of sessions, and we will arrive all the way to the 2nd of December. All right, so meanwhile, I do not see other questions yet. So, but what we would love to to hear from you is your feedback, which is particularly important for us to deliver, as I was saying earlier, to deliver sessions on topics that are of interest to you, right? So if you follow this QR code, you will be linked to a survey, and we would love to hear your feedback. All right, so no more questions as of now in the Q&A panel. And so I would like to thank you all for attending today's session. And I would like to thank Niu-Ching for taking the time to drive us through the content and explain to us all these mechanics and responding our questions. And also a big thanks to Rita, who was helping answering some of the questions in the chat in the panel. So thank you very much, and see you at the next session.
Thank you.